All right, we are dividing fractions. What you see on the board is the definition of reciprocal of a fraction. So it's two fractions that multiply together to equal 1, or 1 whole. The rule for dividing fractions: keep it, change it, flip it. It means keep the first fraction unchanged, keep it the same. The change it means to change the sign from divide to a multiplication sign for the problem. And flip it, you will flip it over and use the reciprocal of that second fraction. So every number has a reciprocal except for 0, and basically that's because 0 can't be multiplied times anything to equal 1. So let's look at an example of how to apply this keep it, change it, flip it rule. First of all, before we do that and jump in, let's talk about, let me see if I can get my pen to work here. Let's talk about reciprocals of numbers. So a reciprocal of 1/4 would be 4 over 1, because I'm going to multiply across the top, and I multiply 1 times 4. The bottom I get 4 times 1, and I end up with 4 over 4, which is 1 whole. So if I was given this as a second fraction, the reciprocal would be 4 over 1. I would flip it. I would take the numerator and make it the denominator, then the denominator and make it the numerator. So another example, the reciprocal of 2/3 is 3 over 2. Notice that I'm switching these places. Okay. The last one I'm going to do is 8. The reciprocal of 8, well, 8 is understood 8 over 1. Any whole number is over 1. And so if I flip this, it will be 1 over 8. So the reciprocal of 8 is 1/8. All right, the reason we needed to know that is because when we divide fractions, in this example here, I need to know what the reciprocal is to be able to solve it. So the rules say keep it the same. So I'm going to keep 7/8 unchanged. Change it, and I'm going to change this from divide to multiply, and flip this one, meaning I'm going to change this from 15 over 16 to 16 over 15. And now the problem that you have down here is multiplication. You multiply across the top, across the bottom. Simplify where you can, either in the problem or after at the end. Remember, that was that personal preference. And so I'm going to go ahead and divide here by 8 on both of these because I see that to be an easy choice. So I end up with 2 and 1. Now I multiply across the top, 7 times 2, across the bottom, 15 times 1, and I end up with 14 over 15. And 14 over 15 is in lowest terms, and so this is my final answer. So we're keep, change, flip to get it set up into a multiplication problem. And then you're going to simplify either in the problem or at the end, but you're going to multiply across the top and across the bottom to find your answer. So this one looks much harder than it really is. And all this says is, remember, fraction bars mean divide. And so it just says that fraction on top divided by the bottom fraction. So when we write this out, I have 4/5 divided by 3/10. I keep it the same, change the sign to multiplication, and flip this one over. I notice that I can divide by 5 in the diagonals. I get 2 and I get 1. Remember, I'm marking out what I don't have anymore and circling the number that I now have in its place. I multiply across the top and across the bottom, and I end up with 8 over 3. Until now, we've been having numbers that are proper fractions, but in this case, my numerator, or my top number, is bigger than that denominator. So to change this into a mixed number, remember this is a division problem, I have 8 divided by 3. Well, 3 goes into 8 2 times, which is 6, and I get a remainder of 2. So I want you to see that this 2 up here is my whole number, 2. The red number down here, that remainder of 2, is my numerator, and the denominator that I already had is 3, and so 2 and 2/3 is my final answer for this problem. Okay, let's try another one. 5 divided by 1/4. We've already talked about this a little bit, but what is 5 as a fraction? Well, any whole number is a fraction over 1. So I'm going to keep it the same, change it to multiply, and flip it over. I cannot simplify in any of the diagonals because of all the 1s in the denominators, so I have 5 times 4 and 1 times 1, which becomes 20 over 1. Remember, if it's over 1, it's just a whole number. So this final answer is just 20.